Hey guys, welcome back. Today is our final lesson on Unit 4, which is all about stoichiometry. So basically what we're doing today is we are taking everything that we've learned in this unit so far and we're putting it all together. So there's not going to actually be any new information in terms of having to learn new steps of anything. This is going to be taking what we've already learned and just applying it to more complex problems, essentially. Okay, so if you've already done lessons 1 through 6, this one will be just pulling it all together and doing some more difficult problems, essentially. So without further ado, let's get into it because I'm sure you guys are probably ready to wrap up this unit. So we have been building up to this moment. Okay, so we're going to put what we learned about the mole conversions and mole ratios together to essentially do multi-step conversions. Up until this point, we've either done like single conversions or maybe two-step conversions, but today we're going to figure out how to figure out any conversion using something called a stoichiometry map. Right, so this map is something that you guys can make a copy of. You'll have access to it in the slides here, but it will be something that you can have with you on your test. So you can pull it up with you when you're taking your test and your study guide tomorrow. But just make sure you have it with you because it will help you to answer these questions. So this is a stoichiometric map. Okay, basically what it does is it shows you how you can go from one unit to another, and it shows you exactly what conversion factor you need to use. Okay, so the units are in the boxes, so like we have grams, particles, volume, and then we can convert with moles, and then we go to grams, particles, volume. So these are all of the units that you could wind up with. And then the arrows tell you the conversion factor you need to get there. So for example, like here in the corner, to go from grams to moles, we would have to use molar mass from the periodic table. So it tells you that conversion factor. To go from a moles to a given to moles of unknown, you would need to use your molar ratio, okay? So the boxes are the units, and the arrows are going to be your conversion factors, okay? So in some cases, you'll be given the conversion factor. So like Avogadro's number is 1 mole is equal to 6.022 times 10 to the 23rd particles. That's a standard that will never change. But in some cases, you'll have to solve for the conversion factor. So like if it's molar mass, you'll have to use your periodic table. Or if it's the molar ratio, you'll have to use the balanced equation. That's why I'm saying if you have not done units or lessons 1 through 6 at this point, you have to go back and do them, or else these things make absolutely no sense to you. Okay? So let's take a look at the steps and how to do this. Number 1, we're going to determine what we're given to start our path. And then we're going to determine our unknown to end our path. And we're just going to use this map to help us kind of visualize what conversions we have to do in order to solve our problems. So this is going to be the example we work through in your notes, and then you'll do some more in your assignment today. So it says the average human requires 120 grams of glucose per day. That's C6H12O6. How many grams of CO2 are required to produce this amount of glucose in plants? And the photosynthetic reaction is 6 carbon dioxide plus 6 water will yield 1 glucose plus 6 oxygen gas. And that is your balanced equation. Probably going to have to use mole ratios here. So remember, when we're doing mole ratios, we're just using the coefficients. So basically, anytime we have a problem, we always try to figure out what do we have, what is the problem giving us, and what do we want to figure out. Okay, so we know that the average human requires 120 grams of glucose. So that's what we're starting with. We're given that we are starting with 120 grams of glucose. And we want to know how many grams of CO2 are required to produce this amount. So we're starting with glucose. So we're starting with grams of glucose. And we want to finish with grams of carbon dioxide. So let's use our map to help us figure out what conversions we need to do. Okay, we're going to count the arrows to determine the length of our problem. So we're starting with grams and we're ending with grams. Okay, so we're starting with grams of glucose and we want to end with grams of our CO2. Okay, so this tells us in my problem I'm going to have to go from grams to moles, moles to moles, and then moles to grams. Okay, so we're going to have to use our molar mass. We're going to have to use our coefficients, our mole ratios, and then we're going to have to use our molar mass again. Okay, so this is the order we're going with: grams to moles, moles to moles, moles to grams. So we're starting with our grams of glucose. We'll use our grams of glucose to calculate our moles of glucose. We'll go from moles of glucose to moles of CO2 using our molar ratios. And then once we have our moles of CO2, we can go to our grams of CO2. Okay, so this is the path we're following on the map. So then we can set up our T-chart. You can do this as you go, or once you know the number of steps you have, you can set it up all in one line. Okay, so as always, we're going to start with our given in the top left corner, and then our unknown will go in the last upper box, because remember, we always want to end with whatever unit we want to end with needs to go in that upper left or upper right. Okay, we'll need our conversion factors, and then we'll fill in the boxes to cancel out, just like we've been doing. Okay, these are just conversions, but we're just adding multiple steps in. Okay, then we will calculate by multiplying across and then dividing. Okay, same thing we've been doing, just a little bit more intense today. All right, so let's go ahead and set it up. So either you can do this as T-charts or in fractions. I personally love fractions because I feel like it helps us keep the math portion a little bit more visible, but however you want to do it is fine. Okay, so we're going to start with our given, we're going to end with our unknown, and then our conversion factors are going to go in the middle. Okay, so we start with 120 grams of glucose. Okay, and based on our map, we have to convert to moles of glucose. Okay, so to do that, we're going to put our mole in the top box because we know we want to go to moles, so we're going to have to eliminate our grams. And this 180, where does this come from? Okay, where did we get this 180? That comes from your molar mass on the periodic table. 6 atoms of carbon plus 12 atoms of hydrogen plus 6 atoms of oxygen will equal 180 grams. So you have to go and get the molar mass from the periodic table, and you have to add it up. Okay, so again, in case we forgot, let me pull up our periodic table really quick. So in case we forgot where that came from, carbon is 12.011. So we would do 12.011 times 6, because there's 6 of them in glucose, because it's C6. Then there's 12 hydrogen, so we would do 1.008 times 12, and then 6 oxygen, so 15.999 times 6, and add that all up to get 180. Okay, so that 180 just comes from the molar mass. Okay, so here we can already see our grams are going to eliminate, and we would be left with moles of glucose. We don't want moles of glucose, we want moles of our carbon dioxide, so CO2. So now we can use our mole ratios from our problem. Okay, so we want to get rid of moles of C6H12O6, which is glucose. So if we're going to eliminate our moles of glucose, the glucose ratio should be on the bottom, so the coefficient of glucose should be on the bottom, and then our coefficient of carbon dioxide will be on the top. So there are 6 moles of CO2 for every 1 mole of glucose. Okay, so there's our mole ratio. So now we've gotten rid of our grams of glucose, we've gotten rid of our moles of glucose, and now we're at moles of CO2. But we don't want moles of CO2, we want grams of CO2. So we're going to do that one last conversion where we eliminate our moles. So for every 1 mole of CO2, we would have 44 grams of CO2. And again, that comes from your average atomic mass to calculate the molar mass from the table. So 1 atom of carbon, so the average atomic mass of carbon, plus 2 atoms of oxygen, so 2 times the average atomic mass of oxygen. Add those together to get 44, okay? So now to do this math, we would do 120 times 1 times 6 times 44 divided by 180 times 1 times 1. So essentially you're going to multiply it through the top and then divide by 180, okay? Which will give us 176 grams of carbon dioxide, okay? And that was a multi-step conversion that you do with your stoichiometric map. Again, these conversions are not anything new. You know how to convert from grams to moles. You know how to go from moles to moles and then back to grams. These are all examples that you have done already. The only difference here is that now you are, doing multiple conversions and multiple steps, okay? If you take it one step at a time, you will absolutely positively be okay. So again, I just wanted to bring this map up one more time and show you that all the conversion factors are there for you. So if you can just follow the map and make sure you do step by step. So like in what we just did, we went from our grams of our glucose. We used our molar mass of glucose to give us our moles of glucose. Then we used our molar ratio to go from moles of glucose to moles of CO2. Then we used our molar mass of our CO2 from our table to go from moles to grams of CO2. Okay, if you just follow the map and do the steps in order, you'll be golden. I know that this stuff can be tricky. Trust me, I understand it. But if you take it step by step and you use your map, you will be okay. And again, just a reminder, where it says molar mass, you have to calculate that from the periodic table. So I'll have the periodic table linked and also a calculator linked for your assignment today. So if it says molar mass, you have to use the periodic table. Molar ratio, remember you have to use the balanced coefficients to figure out the ratio. And then Avogadro's number is 6.022 times 10 to the 23rd is equal to 1 mole. Okay, that's a constant that won't change. These are volumes, so 1 mole is also equal to 22.4 liters. There aren't any volume problems on your assignment, and there won't be a volume problem on your test either. However, you should be able to do these conversions just using your map. Okay? I will have another example in your assignment today, of course, but we'll do some more work with this on our study guide and then in class before you guys take your test for this unit, because I definitely want you to get plenty of practice and feel comfortable with these before testing you on them. If you have any questions, let me know, and if not, you are on to your assignment for the day.